We're going to focus now on more problems with messier multiplicities. So you'll see that a lot of these will come to you factored, because if that was all multiplied out, we probably wouldn't get very far trying to figure out how to factor it. So we get to jump right into trying to spot our global and local behavior. So first thing, if I'm trying to figure out degree and global behavior, I'm going to imagine that out of this first one, I get an x cubed. Out of the second one, the biggest power I see is going to just be a 2 times x. And then out of the last one, the biggest thing I get would be an x squared. So when I multiply that together, I'm going to get a positive 2x to the 6. So it's degree 6. And my global behavior is going to be like a y equals positive x to the 6. And this is going to tell me that as x gets really, really big, y is also going to get really, really big. We should be picturing basically a right side up parabola. And as x gets really big negative, y also gets really big positive. Okay, so we've got all of our global behavior. We also need some zeros and their multiplicity for our local behavior. So factor number 1 will equal 0 if x is equal to 0. So the intercept is 0, 0. That does have a multiplicity 3, and multiplicity 3 means you will cross the axis, but you'll make an inflection point, a little flat spot, right where you cross the axis. So it should look like your y equals x cubed shape when it crosses. It could be upside down or right side up again, but it should make that funny flat spot, and the bend should change. The next factor, 2x plus 5, that equals 0 if x is negative 5 halves. And I'm guessing a lot of people are getting pretty good at just spotting those. But always remember, if it looks a little messy, you can set this equal to 0 and you can just algebraically sort through to make sure you don't mess up any signs. So there's our negative 5 halves. So totally up to you if you want to show work on that or not. I do believe that you can probably spot those without the work most of the time. And then last is going to be a negative 6, 0, and that is a multiplicity 2. So I will expect to see that sort of bounce off behavior right at negative 6, 0. And again, it could be above or below the axis, but the bounce off is key. The sign will not change if there's an even power. Okay, I'm going to sketch right underneath the formula. So key points, I need to get all the way out to negative 6. And I'll go to positive 6 on the other side. That's more than enough. And the intercepts are negative 6, 0, positive 1, 0, and negative 2.5. Okay, global behavior says I should start from positive infinity. And at negative 6, that was my multiplicity 2. So I'll need to bounce off the axis. I'm going to give myself a little more room. Coming down at negative 6, I'm not going to cross. I'm going to bounce off the axis. And then I will need to head up a little and then turn around and come back down. And at negative 5 halves, that was multiplicity 1, so I really can just cross through. Again, the idea here is that if you zoom in, what you see there should just look like a straight line, a first degree. And here, if you zoom in, no matter how far you zoom in, if you stayed centered on that x-intercept, you'll always see that x squared shape in there, and that's what you should see. Last one, we need to come back up, and this is multiplicity 3, so make sure you exaggerate these so I can tell. Sometimes people just don't do that very much, and I'm not sure. So it should make a flat spot there. It does cross through. Hold on, mine looks like it's moved over a little bit. So it does cross through, but it makes a flat spot as it's doing it. And again, with that one, if you started zooming in, you should be able to see that concavity change. We have this downward bend followed by upward bend. That's an inflection point. You should see that as long as you keep your window centered on that point, no matter how much you zoom in. Okay, I think that's good for that one.